Now as you can see, we can say that OP is equal to OQ, which is radii. Now we have to show that PBQ is equal to BQD. PBQ is equal to BQD. Now in such an instance, now this is how you build up your thinking pattern. You should know that, right? If PBQ is equal to BQD, if PBQ is equal to BQD, what is the reason for them to be equal? If they were to be equal, what is the reason? We can see that AB and CD are two tangents. If they are two tangents and if AB is parallel to CD, then angle PBQ will be equal to BQD by alternate angles, or as what we call as Z-shaped angles. Now children, if these two lines are parallel, then of course these two will be equal. Now show that PBQ is equal to BQD. Now if these, obviously these two are equal, that is why we have to show them. So if I could prove that AB and CD are parallel, then our life will be much easier. Since we know that OP and OQ are radii, I can say that these two angles are 90 degrees each. Why? Angle OPB equals OQD. Radii meeting the tangent. Radii meeting the tangent. We also know that if these two angles adapt to 180 by allied angles or by interior angles or C-shaped angles, they adapt to 180. So now they adapt to 180, 90 each. Therefore we can say that since OPB plus OQD equals 180, AB is parallel to CD by allied angles. They are parallel. So AB and CD are parallel, therefore by allied angles we can say that these two are parallel. So again, now we can say that since they are since they are parallel, these two angles are equal. So we have proved that these two sides are parallel. Once you prove that these two sides are parallel, then by alternate angles these two are equal. So once again we came up with a theory from here. What if they were equal? For them to be equal, then these two should be parallel. We proved that these two lines, the tangents AB and CD are parallel. They are in, obviously these two angles are equal.